Let me introduce my colleagues, starting at the far end of the table. Lou DeAndrea, followed by Ian Hutchnicki, and finally Nick Lair-Revere.
Very good.
So the biggest thing that came into Mathematica 9, or one of the biggest things that came into Mathematica 9, was the predictive interface. And Chris Carlson was the lead developer of the predictive interface. And Lou, you had a lot of time to work with Chris on this. And very exciting new feature, many elements to it. Show us what the predictive interface really is inside Mathematica 9.
Right. So one of the key themes of Mathematica has always been automation. And in the past, Mathematica's automation has sort of been restricted to computations. So you type some input, you press Shift-Enter, you get some result, and it's that computation that's automated. But the typing is still, something that's grunt work you have to do. And then when you get the output back, you have this piece of output, and maybe you can access it in the Mathematica session using some reference to it. Maybe you copy and paste it or export it. That's how things have been for a long time. Starting in Mathematica 6, we extended this automation to, well, now the output is not quite the end of the story. We have the ability to have interactive content where you can drag sliders around. We've taken this automation to the next level in Mathematica 9, where the output is no longer the end of your story. So we have several aspects to the predictive interface listed here: the suggestions bar, which I'll be talking at length about, the input assistant, and some other very useful features. But the point is that this is automation that you can use to immediately sort of get up and running in your Mathematica session. So let's take a look at the suggestions bar. So in Mathematica, you type some arithmetic. This is something that even a starting user might type in, and you get some results. So the question is, what do you want to get back? So what has actually happened here? Mathematica has taken a look at your input and output, analyzed it semantically, run it through thousands of heuristic rules that have been gleaned from Wolfram Alpha and a few other places, and produce sort of a top number of suggestions for this particular input. The top 4 are produced at the top of the suggestions bar, and many more of them are available through the More tab here. So this suggestions bar is attached to the output. If you start typing some new input, note the suggestions bar disappears. You get some new output, and it comes back. You're interested in going back to the suggestions for this guy, click, and they're back. The point of the suggestions bar is to give you instant access. Well, there's a couple of main features that I'd like to point out. One is it gives you instant access to a wide breadth of Mathematica functionality without needing to know the syntax for it. So it serves as an advertisement for some of the features that are available in Mathematica, but also as a convenient way to explore those features without needing to have a trip to the documentation, without needing to type anything. So if we want to, for instance, calculate the average of the elements in this list, we click the mean button, and what is the numerical value for that? So the predictive interface gives us at our fingertips, without having to type much of anything, the ability to explore quite a bit of Mathematica. Okay. So some of the other aspects of the predictive of the suggestions bar that I'd like to point out is that it's not always the case that there's a single Mathematica function corresponding to a particular suggestion. So here we have a complex number. For some of these suggestions, the magnitude and the conjugate, these do correspond to single named Mathematica functions. But the convert to exponential feature of the suggestions bar does not. There's a one-liner that will give you that will do this for you, but Mathematica by default will not show you that one-liner. It will just say, oh, you wanted to convert this? Here's the result. And if you're interested in learning about the input that does this, you can take a look in this way. So this is beyond just sort of a simple wrap a function around the previous output. Here's another example of that. So we have here a trig function of 3 parameters. And if you encountered this trig function in your trig class, you might expect that the x parameter is actually the independent variable, and that a and beta are some other parameters that you might want to investigate the space that they determine. And indeed, that is exactly what this plot button also assumes. So the suggestions bar, uses Wolfram alpha heuristics and sees that x and knows that that is probably what you want to be the independent variable, and it constructs this plot command wrapped in an interface command, so you have an interactive widget for exploring the space defined by this simple trigonometric function that you've typed in. So very powerful to get sort of up and going. Lots of automation involved here. Another nice automation feature is the so there are certain functions in Mathematica that are very powerful. The transpose function is an example of such. It's very, you can do lots of things with transpose to rearrange three-dimensional matrices of any dimension. But actually using the transpose function occasionally takes a trip to the documentation or a little bit of experimentation to figure out exactly what command, what argument you want to give. And we recognize that this is how people work, and the suggestion bar attempts to automate this procedure. So rather than doing a single transpose, this button brings up within the suggestions bar some of the choices that you might have meant. So here is a summary of what would happen if you called transpose with a particular second argument. This is the result that you would get, and these are the dimensions that you would see. So in this way, we've taken the busy work of typing all these in and trying to figure out which of them you want. And let's say you knew that you wanted this particular dimension set, so yes, this is the transpose that I want. Click it, and we have now the input exactly that we wanted. So this is, I'll point out that this is useful not just for novices, but transpose, even if you use it every day, you might have trouble remembering the subtleties of its argument structure. So you avoid going to the documentation, and this is useful even for experts. Another thing that experts tend to do in the documentation is to explore the space around a particular function. So Mathematica has lots of introspection functions. We have $version, we have system information, we have lots of other related functions. How could you possibly learn about these without going to the documentation? Well, that is now a question that can be answered via the suggestions bar. The output to $version is a string, so by default we get lots of string predictions. But if we say that we're interested not in the output, but more in the input, here we have now instant access to many of the introspection features in Mathematica. So in addition to $version for the version of the kernel, we can get information about your session ID, information about your operating system, and so on. So in this way, you can think of this as a see also on steroids. This is a very useful way to explore the spaces of related inputs in Mathematica 9. Another strength of Mathematica 9 is in image processing. The version 9 features of image processing have been greatly expanded, and there's lots of wonderful documentation that you could read in order to come up to speed on using it at a very low level, very powerful functions. But what if you just want to get something done, something simple? What are the other possibilities that you can rely on? So the suggestions bar gives you, in this example, gives you the immediate access to lots of image processing functions. If we open up the More tab, we see, I don't know, maybe a total of a couple dozen. Several of these are also menus, so let's say 3 dozen different image processing functions at your fingertips without needing to go to the documentation. So let's actually try a couple of these. Blur, quantize, let's say I want to try blurring this. Well, now within the suggestions bar, we have an interface for interacting with some interactive widget. I don't yet know the name of the Mathematica function that does this blurring, but in fact, I'm actually doing it live. And if we click done, let's say that's the image that I want, and we see Mathematica reflects back that yes, this was the blur function, and it has a second argument. If you're interested in what it is, you go off to the documentation and read about it. But if you just want to get stuff done, you've gotten stuff done already. Let's say that's not quite the filter I wanted. Let's look at, I don't know, gradient filter. So here's another interface for interacting with a radius. And okay, so we have some sort of charcoal looking version. So we have a couple now variations on this image. Say we also wanted to look at a comparison between these. So let's say we want to dissolve between these two filters. We want to compare this output with some previous output. Well, in previous versions of Mathematica, that would mean scrolling up and doing a copy and paste, or possibly looking and see how to refer to the previous output. But in the context of the predictive interface in version 9, we have the ability to automatically populate an interface element with all of the images that are appropriate to compare with this image. So instead of needing to copy and paste, we just come down here and say, this is the image I want to compare it with, and now the result of the suggestions bar is an input that creates an interactive widget that allows you to dissolve between your two filtered images. Okay, so again, automation is the key here. There's another very common way that people work that we can automate. So let's say that we have, we start with some graph theoretic expression, and let's take a look at its, adjacency matrix. So this is a sparse array. Let's see, let's try to visualize that array a little bit, get a sense of what it looks like with array plot. Okay, that's a little big for my screen. Let's make it a little smaller. Okay, now I've done a sequence of steps here, and one of the most common things you might think of to do next is, well, this is now what I want. I've gotten to an endpoint where I want to be. How do I take what I've done and roll it up into a single Mathematica command? And so the predictive interface allows you exactly that feature. This spiral icon at the end, so if you click it, it will take all of the inputs that you've just created via the predictive interface in the suggestions bar and roll them up into a single input, so that you can now have, your notebook isn't littered with a bunch of intermediate things. You've gotten to your endpoint, you have a single function now, and you could still have predictions that run off of this. So if you wanted to continue on and export this to another file, for instance, you could do that as well. So there are some other things that I'd like to point out about the suggestions bar. Next to the roll-up button, there is a button for sending things off to Wolfram Alpha. Starting in version 8 of Mathematica, I believe there was the features to access the Wolfram Alpha API directly from within Mathematica, and this button will call those features with the value of the output. Another very important button on here is the feedback button. So Mathematica 9 marks the initial release of the suggestions bar, and we're still very actively working on it. But we very much want to hear your opinions on this. So if you're a Mathematica 9 user and you're interacting with the suggestions bar and you have things that you want to see or you'd like to see removed, we very much want to hear your opinions on this. And then we have this minimize feature as well to take it out of the way when you don't want to see it. By the way, if you do submit feedback through the feedback feature, you might be surprised at how frequently you're going to get updates to the predictive interface framework. So it's not the case that you'll have to wait for the next release of Mathematica to get new predictions in your Mathematica. The predictive rules are implemented as a data packlet. For those of you that don't know what a data packlet is, that's fine. It just means that we can stream out new versions of this from our servers that your Mathematica will automatically take advantage of. So you might get new predictions from one day to the next just by launching Mathematica and using it in the typical way. And so we can act on this feedback in a very sort of timely manner. We can make our heuristics smarter, and so on. Okay, so that should give you sort of a summary of what the suggestions bar aspects of the predictive interface are. Good for beginners. There's lots of richness there. For people that are already topical experts, it's nice to sort of see similar functions to the functions you're used to seeing and rounding out your knowledge. And of course, for experts, this isn't just a tool for new users. This is very useful for experts as well, for the convenience factors and for taking your prowess to the next level. So that's the predictive interface.
Now, Lou, you showed there briefly how you can minimize it. Mm-hmm. Can I turn it off completely?
Sure. If you find that you don't want to see this appearing after every output, even in minimized form, you can open up the preferences dialog, and at the bottom of the interface pane is a checkbox for turning it off. But don't do that, because it's a great feature. You shouldn't turn it off.
We don't want you to do
But if you
that.
have to turn it off, that's where you would do it.
Now, what if a user really, really loves this and they want to customize it? Is that possible?
Right. It's not possible at the moment. We are going to be working extensively with Mathematica developers in order to make the heuristic mechanism updatable, and so that it's a little bit simpler for people to use. So right now it's sort of highly technical, and there's a lot of ducks that you need to get in a row in order to add new rules. But we hope to simplify that and release a developer API soon.
Great. Lou, thank you very much. Certainly one of the great new features inside Mathematica 9. Another great new feature inside Mathematica 9 that kind of goes along with that is the predictive interface is the input assistant. And Ian, tell us about the great input assistant.
Sure. So for version 9, we spent a lot of time working on making it easier for users to be able to take advantage of all the capabilities inside of Mathematica. And part of that was the suggestion bar Lou just finished describing to us. But the other part to it is also what we call assistants. Assistants are basically tools to help you accomplish particular tasks. They are narrow in scope, and they basically help you do what you need to get done quickly. And for version 9, we have 2 of them, and we'll have many more, I'm sure, in future versions. But today, I'm going to talk to you about the input assistant. The input assistant is actually a collection of tools inside the interface that help you develop your code for either your package, your application, or your documents. Those contain basically of auto-completion, we have function template insertion, and then we have new in version 9 dynamic highlighting, which I will describe later. Auto-completion actually existed inside of previous versions of Mathematica in a somewhat similar form. We've expanded on it greatly for version 9 to make it more useful. As you can see here, the list is much shorter than you typically would see in previous versions because we put the most frequently used functions first. In case all the choices that are presented aren't the one that you were looking for, you can expand it clicking on the expansion button at the bottom, and it will show you the remaining symbols. There's also a link in the upper right-hand, in the right-hand portion of it for each symbol that will take you to the documentation in case you're interested in a particular symbol that you may not have used before and want to know more about it. The biggest part for auto-completion in version 9, though, is the fact that it is learning now. If you notice, I said most frequently used, and that's absolutely the truth. The more that you use auto-completion, the more it will learn which symbols you prefer to use, and they will slowly begin to move their way up in the listing, so that way you can work and get what you need done faster, which is a really neat feature. And much like version 8, the completions menu is used for both system symbols and user-defined symbols. So if you're interested in looking up plot3D, it's just one click away. Temporary directory as well is just right there. It saves you a lot of time typing out very long symbol names, especially ones like your user-defined functions. Now the interesting bit with the user-defined functions are that in previous versions they would be listed alphabetically so that they would be lost in the mix. In version 9 we've made it so user symbols percolate their way to the top because they're more frequently used in context than system symbols. And that's the same true for variables as well. One of the most requested features for completion has been options. Options, a lot of our functions take very many options, and it was always a feature that was highly requested, and so for version 9 we actually made it so we can do option completion. Here I have a plot that I'm not particularly fond of the color. So I'm going to change it, and lo and behold, this gives me a completion list of only the options that are available for plot3D. And then when I insert it, I get a nice little template to help you fill in the rest without having to worry about all the structural bits behind it. So now I've just changed my plot to something that looks a little better, in my opinion. The other important thing is that completions, option completions know about the function that they're associated with. So here I have a clock gauge, which clock gauge is new in version 9. And it's a clock. I would like it to update on a 1 second interval. So me just being me, I'm going to try and type in update interval. But update interval doesn't apply to clock gauge, so it will not complete. However, if I would to do dynamic, if I could type it correctly and insert it properly. But see, update interval now shows up in the completion listing there. This, in and of by itself, has saved me arguably large amounts of time as I'm writing things. And while we were in here, you might as well keep going. So instead of just doing options, we also complete contexts. I'm notorious for using exceedingly long context names. Why, I'm not 100% certain, but I do. And so it makes it really convenient so that you can actually, when working with packages, or in my case, just context in general, it's very easy to actually complete them. So you don't have to type them all in. What makes it even more convenient is that you can chain them. So I can actually get to fully qualified symbol names with relative ease, which just makes, and that for me can actually take quite a bit of time to actually type in, and I can just do it in just a few keyboard events. We also did it for character completions. Long names are the honest to God truth in terms of naming. They are long and quite, but they're awfully terribly useful to use in general. So for long names, you can actually just do integral, and you'll get a listing of all the characters that match the long name that you start typing out. So here I'm going to write just a silly little integral, and it also works with escape sequences as well. So aliases are sometimes harder to remember than the actual long names themselves. So this makes it really convenient to be able to work with special characters easily. And it also works for, here's a good example of one that's actually really long to type. And it gives you a various list. There's some of these in this list I didn't even know that we had. And it's a nice way to discover new characters that you might not have known that we actually supported. So that's completions. And new for version 9, we also decided that if we had all these really nice completions, it would also be really nice to have all of the function templates that actually be usable, as opposed to in version 8 where it just inserts a single template, which a lot of our functions have multiple signature types to it, and it would always be nice to have the ability to select which one you wanted inserted. Here's the general interface for it. It gives you a list, gives you the usage description, so that way you can actually, if you've never used that particular signature before, you can actually read up on it and understand it, and if you want, you can click on the documentation link to learn more. If you may or may not have noticed, but when you insert a completion, you'll get this little drop-down arrow here, which you can click on, and that will actually bring up the exact same listing that I just have here. Makes it really easy to use. And here's just a trivial little example. I have an image. I don't do image processing very often, so when I do, I typically don't have all these things off the tip of my tongue, but I have a manipulate here that I know I want to do. I know I want to do image resize. There we go. That's the thing I was, resize. That's the thing that I was looking for. I have image. I know that, I know that I want to vary the width and height independently, so I'm going to insert that guy for it. And there's my image, and we have width and height. And then for my manipulate, I want to be able to modify the width from 10 to, let's say, 128, and the height from 10 to 128. So there we go. There's my quick little manipulate that allows me to do it. But I was able to just use the function template to actually insert the signature for the function that I don't typically use and have remembered off the top of my head. So that's function templates. And The third final bit to the input assistant is dynamic highlighting, which is arguably my favorite feature in version 9, because I often work with code that comes from other users, either internal or external. And so dynamic highlighting helps me understand the structure of this piece of code that I happen to receive from someone. It allows you to always know exactly where you are. In version 6, I think it was, is when we introduced syntax coloring. And in version 6, how I would do this would typically be I'd end up having some deeply nested list structure, and I'd end up ripping out the trailing, braces to actually see the match on, in syntax coloring elsewhere, because it's a lot easier to see color on a white background than it is to actually try and count all these physical little braces along the way. So it has saved me so many hours of just clicking to expand my selection to try and figure out exactly where I am. Some common examples for dynamic highlighting: they work for lists. They show you, braces. They work for precedence, so for parens. They obviously work for functions, of course. It gives you a nice little way to know what function you're in. It works with complex function heads, which is really nice. So if you have f of g of h of args, it will actually parse the expression, so you know that the head of this is f of g, and then if you go one level deeper, it's f of g of h. It works for pure functions, which I use pure functions a lot, and it's nice to know that inside of my body here, that the head of it is actually the function, the ampersand. And it'll of course show you that the entire pure function is the head of this. It works for prefix and postfix operators. Obviously that's pretty self-sufficient there. It's really nice for postfix because sometimes that gets lost really easily because it's a side effect. It's off to the side, separated from the rest of it. It also works in output cells. This I use more often than anything because a lot of times I work with the XML, so I'll do import of some piece of XML, and you'll end up getting back a very deeply nested structured piece of structured data, and it's really nice to be able to go, oh, the element, the head of this element is this other element up here. It's very easy because it's very easy to lose track of where you are, and it also works as well, with functions in output as well. There's some places that it won't. Obviously, if it doesn't have a head, it doesn't actually highlight, and you don't need it when syntax coloring is involved. So for comments and strings, it's already pretty obvious exactly where the bounds of those are. And if you're curious to know more about the input assistant, there's some links here in the documentation center to not only just how to use the input assistant, but also the predictive interfaces in general. And hopefully with the input assistant, we can help you write better code with less errors.
It's certainly a great new feature of Mathematica 9, and new users to experienced users can certainly find a lot from it. And my one question is, can you customize it at all?
Oh, yeah. I mean, other than the fact that, as you use it, symbols will move their way up and down. You can actually control the colors that are used for the highlighting inside of dynamic highlighting, of course. And then you can obviously, if you prefer the more manual approach, you can obviously turn it off. You can also change the delays of how quickly you want the menus to actually pop up.
Well, to learn more about the input assistant, like Ian mentioned, go ahead and visit the documentation center. Another new feature of Mathematica 9 is units, a very exciting one that users are really getting a lot out of. And Nick, tell us about units in Mathematica 9.
Yeah, sure thing. So in addition to some of the user interface improvements we've made in Mathematica 9, we've tried to focus on a lot of different application areas that we've had in Mathematica. And one of the things we've spent a lot of time working on updating is Mathematica's unit system. And so what we've done in version 9 is we've taken a lot of the lessons we learned with Wolfram Alpha and building a very large comprehensive unit system and seeing how people interacted with it in a web environment, is we've adapted those lessons into Mathematica for computation purposes. So what I'd like to do today is just give a brief overview of some of the areas of functionality, starting off with unit discovery, how we interact with Wolfram Alpha and how we deal with interpreting different units, then look at unit conversions and how we handle things like unit systems and simplifying complex units, and then look at some interesting real-world problem solving. Mathematica 9 includes thousands upon thousands of different units, and we're always looking to expand that unit base. So it was easy to start off and look at just adding SI units across ISO standards, which is the baseline that we use within this unit system, but we wanted to expand it and handle all sorts of different application areas. There are lots of specialized units that come up in chemistry or in physics, or that come up based on international treaties where you'll have 9 different definitions of a foot, and we wanted to include as many of those as possible. And so what we've done is build a unit system based around all the complexity of unit systems in all their different application areas and pull those into a unified environment and let Mathematica's built-in tools help you navigate that. So we'll start off with unit discovery. One of the problems with having a whole lot of different units is sometimes it's hard to get started with those. Being able to leverage the techniques we've put together with Wolfram Alpha and the Wolfram Alpha interfaces makes it really easy to get started with this unit system. So the easiest way to get started working with different units is to just type those in a natural language environment. The control equals interface, which has been in Mathematica since version 8, allows me to enter in natural language and it will return a Mathematica expression that corresponds to it. So I can say I want 13 feet, and it will go off and communicate with the servers and tell me that the interpretation of that is 13 feet, and I can look at the input form of that, for example, and see what the underlying expression is, which we use a wrapper called quantity that lets us keep track of. This is 13 feet, it's not 13 times feet, for example, which is really important with a lot of different units. In addition to what we stereotypically think of as units, we've also included various physical constants. So I can ask for 0.9 times the speed of light, and that will be returned back as a quantity expression that's returned in terms of the speed of light. We don't just say, oh, it's about 300 kilometers per millisecond. We actually treat that as a standalone unit that can be combined with other units as well. The nice thing about this control equals interface is it's really easy to use this natural language directly inside of evaluations and other functions in Mathematica. So if I want to convert the speed of light into feet per second, I can use the control equals interface to do that directly. I can also enter directly in. If I want to use a different display form, I can grab either the input form of that or the output form and evaluate that easily, or get a numerical approximation. Because we have so much curated data in Wolfram Alpha, one of the things that it lets us expand is that we can solve problems related to known data sources without having to do a lot of specific looking up on our own. If I want to figure out how many sheets of standard printer paper will fit on 1/4 of an acre, I could go and try and look up that, I know that it's going to be 8.5 inches by 11 inches, which is going to be about 100 square inches, but I can actually send those sorts of queries directly using this Wolfram Alpha interface and get back an exact value based on the inputs that I have here. So I know that there are a little more than 16,000 sheets of paper that could fit inside of 1/4 of an acre, or maybe I want to scale that up to 2 acres. It will modify the input for me, and then I can see how that value scales. You can also work directly with the quantity expression itself and insert natural language, which we will use the Wolfram Alpha technology to go ahead and interpret, and then we'll cache those values so that we can use them in the future. And this allows us to work with a lot of heuristics. One of the problems with the units is that they have short names, but those short names can change based on the context. So if I enter 1m, we interpret that as meters. If I enter m divided by s, we interpret that as meters per second. But if we do mps, we're actually generally referring to miles per second, such as mph is miles per hour. So we've been able to incorporate a lot of the technology that's pre-existing into generating a really complicated unit interpretation system that flows very naturally. We can also use these expressions in things like bar chart, and we can get a really quick visual comparison between different measures of volume. So if I know immediately that a British gallon is larger than an American gallon or a US standard gallon, And we can also see a GIL is a measure of volume that I don't use terribly regularly, but I've heard of it, and I can throw it onto this axis and immediately see what it looks like. Another way that the Wolfram Alpha interface has been expanded to work with units is that we'll communicate directly with our data servers, and we can return information directly to Mathematica with units associated with it. So I can ask for the distance to the moon, and I don't get back just a number, I get back a unit associated with that that's meaningful, so I know it's exactly this many miles. I can also pull up general information, such as if I asked Wolfram Alpha about a Cessna 170, that's a small light personal aircraft, I can look through the various pods that come back and see different properties, but maybe I want to do something like I look at these performance characteristics and say, maybe I want to compare these with a Boeing 747. It's probably not going to have the same performance capabilities, but I can use these interface utilities on the right-hand side, and I can ask for the computable data. I'll get back an input form that generates those, and then I'll actually get back information like the cruising speed in both miles per hour and knots. I can see what the operation ceiling height is, etc. Once we have these units into Mathematica, there's a lot of calculations that we can do that are really interesting. So for example, unit conversion is a very common operation that you might want to take place. You might want to say, what is the speed of light in terms of its base SI units? And we'll get back the exact speed of light, which is just under 300 kilometers per millisecond. We can also use this control equals interface to parse different inputs, and so I can convert 8 square miles into acres very easily and see the values that are associated with that. I can convert a light year, which is a measure of distance, to a bunch of different units and unit systems, and we can see that even though it has a base unit of meters, if we convert it into SI, it knows, okay, kilometers is a more appropriate unit. We have a lot of heuristics that go into dealing with what the normal range of a unit is, etc. And this sort of unit conversion can be useful for answering real-world problems. Some of the college students in the audience may wonder how many bottles of wine you can fit inside of a gallon. And that's something we can compute very easily because we have that sort of information. It's just a little bit over 5, so real-world knowledge at work here. We've also included some sophisticated algorithms that deal with simplifying units. There are lots of different units out there, and we may be familiar with, okay, 100 kilograms times meters divided by seconds squared is going to be 100 newtons, but some of the more complicated components of those we may not recognize immediately. And the unit simplify function allows us to take a quantity expression and it will run through and try and reduce that into a single unit if possible. And if not, we can get a compound unit expression that will be simpler. I've never run across pascals per farad in the wild, but it's nice to know that we can interpret the different components that make that up into something meaningful. So now let's try and do something interesting with these and see what we can use units for in the real world. You may notice a common theme with some of these inputs relating to alcohol that does not reflect on me whatsoever. But suppose I want to find out how many jiggers are inside of a British pint. We've integrated this with system functions such as solve and nsolve, where we can quickly run evaluations with units. We can pull back those base values and we can compute meaningful answers. In addition, we can also add those into visualization examples. So here is a small bullet gauge, which is one of the new gauge functionalities, where I can quickly throw in a reference value of a single jigger, 12 jiggers, which is just under the value, and then the actual British pint, and we can see the relationship that fits between all of these. Let's look at something that's a little less trivial to compute. Let's say I'm shipping a whole bunch of AA batteries across seas, and I need to get a rough estimate of how many of these I can fit onto a shipping pallet. We can pull down information from Wolfram Alpha, such as the dimensions of these batteries, and we can also pull down information like the size of a P6P shipping pallet and throw that into a solve equation and say, okay, we can fit about 1,200 different batteries on there. But we can also complicate that. We can use, for example, a hexagonal packing system for cylinders, and we can throw that into solve as well. Perhaps a little bit less of a real-world example. Randall Munroe on his What If XKCD blog series posed the question, or attempted to answer the question of how much force power can Yoda generate based on information we have from the various Star Wars movies. And one of the things he did was he handled scaling down a real-world object that we have information about, such as an F-22 Hornet fighter. And In fact, one of the things we happen to have in Wolfram Alpha is data about various sorts of aircraft, such as an F-22 Hornet. And I can pull back that information and create a set of rules related to its different dimensions, and then use a basic dimensional analysis formula here. I want to take the estimated mass of an X-wing fighter that was lifted from Dagobah over a certain period of time, and believe it or not, all of this information is documented to some degree or another in various Star Wars fandom sites. So we know that Dagobah has 0.9 times Earth gravity, and we can quickly throw that in and we get back a measure in terms of base units associated with that. We can convert that and say that over that time period, Yoda was able to generate about 20 kilowatts of power, and we also know that's about the same horsepower output as a small sports motorcycle. So knowledge at work here. Similarly, along the same lines, Mr. Monroe also posed the question, or attempted to answer the question of how much energy it would take to take the entire population of the world off the surface of the planet of the Earth. Using the same sorts of information, using Wolfram Alpha, using country data, we're able to take in information such as the average weight of a human adult, the escape velocity required to propel an object from the surface of the Earth, how many people there are in the world, and we can set up, we can quickly get a reference for how much power is actually going to be needed to pull those off. We can pull down other information like the total electrical consumption from the world, which unfortunately isn't pulling back here at the moment, but we can quickly generate information and then throw it into visualization functions, for example, seeing that the ratio of power required compared to total capacity on the surface of the Earth that's able to generate over a period of time. So there's a lot of different things that we can do with units, and hopefully some of these examples have sparked your interest and given you some ideas about exactly what sort of things you can be using the new unit system for.
Well, Nick, one question that I have is, can you define your own units?
So right now, there isn't a system for exactly defining your own units, but you can set up your own sorts of unit relationships. So for example, say my foot is 13 inches long, and I want to know how many of my feet are in a mile. So I can set up a relationship. We use a wrapper function for an inert unit or an independent unit, and we can say there are 13 inches for every one of my feet, and so there's a little bit under 2 within 2 feet, so I can ask for how many of my feet are going to be inside of 3 miles. And we can see, okay, there's a ratio a little bit below what there normally would be in terms of regular feet. So that's something that we're using the principles of dimensional analysis and unit cancellation that lets you leverage and essentially define your own unit relationships.
No, thank you. And if you want to learn more about units, you can head to the Documentation Center. Many of your questions can be answered there. Those are just some of the new features inside Mathematica 9. If you want to learn more about what's new in Mathematica 9, visit wolfram.com/Mathematica.